Lesson 3.2, Solving Systems of Equations Algebraically. So we've solved things graphically. Now we have to ask ourselves, if we have two equations, is there another way to do it? And if you rewrite this equation, but leave a gap where the y is, you can place this in there. We call this substitution. And it's pretty obvious. We take one equation, substitute it in for another one, and then we solve. Then take the one and plug it back in either one. I'm going to plug it into this one. And we have a solution. And just like before, we're not really done until we check it. So we need to put it into the second solution here, the second equation. -1 plus 3 is 2. And I put a little check mark next to it to make sure I've checked it. It's nice checking these because then if you do it right, the check that is, you really should never get these wrong. They should always be correct because you check to make sure that those values actually work in both equations. Here's another one for you to try. Hit pause if you want to try it on your own. So here I go. I'm going to solve it. So there it is, substitution. Let's try another one. We'll do this one together, or you can do it on your own. You can pause the recording. We get 1 equals 5. So 1 can never equal 5. This is no solution. This would be two parallel lines. So we say it's inconsistent. Try it again on this one, see what you get. This one is infinite number of solutions. It's the same line. It's consistent and dependent. So that's substitution. What's another way to do it? We call this elimination. We just put a line under them and add them down. When you add these, you get 0. When you add these, you get 8y. When you add these, you get 24. Y equals 3. Plug it back into either one. You get 1, 2, 3. And we plug it into the other one. -2 times 1 plus 5 times 3 is -2 plus 15 is 13. Checks. So why not just graph or use substitution with this? elimination, as you just saw, is much quicker. It's really the preferred method for solving equations if we have the option. The nice thing about graphing is it's visual. You understand, oh, parallel lines, no solution, same line, infinite number of solutions. So that's why we did that first. And substitution is just another way to do it. Sometimes it sets up nicely, sometimes it doesn't. Elimination is the typical way, is typically the best way to do it. So you can try both these. You notice they're a mess. So what we want to do is line them up. So I'm going to put them over here. And now they're not set up to eliminate, so I have to do something. In this case, I'm going to multiply the top by -3 and the bottom by 4. That way, when I add down, these will eliminate. Then I would always recommend going back to the original equation to see what it is, because you may have made a mistake somewhere along the lines, and this will show it. And at this point, I'm going to do my checks in my head. 6 equals 15 minus 9 is 6. Good. Try the next one on your own if you want. This one's a lot easier. I'm going to multiply by -2. And I just checked it in my head, it works. One final example. I'm wondering if you can guess what's going to happen during this example. Looks like a pretty tricky problem. Actually, I guess it's not going to happen. I thought we'd get a inconsistent or dependent, but you see how those worked. Let's multiply. Well, let's rewrite them. And let's multiply the top by 5, bottom by 3. 15x works. I just checked it in my head quickly with the second equation. So that's it. Not particularly challenging in terms of the concept, but a little tricky with the algebra. There's a lot going on there. So watch out for your dependent, your consistent, and your and your inconsistent problems. You're just looking for those something equals something where all the variables drop out. That's it. Good luck.